Hello and welcome to Lab 3, Part D, Connect Isostatic Equilibrium Observations. In this section, you'll focus on the elevation of blocks created in Part C and connect these isostatic equilibrium observations with measured differences in crustal elevation. In Part C, each model predicted the difference in elevation between continental and oceanic crust relative to sea level. To calculate the difference in elevation between the average continental and oceanic crust, use your data from the models. For example, in Model 1, the average continental crust was represented by Block 2. In Model 2, the average oceanic crust was represented by Block 4. Thus, Model 1 Block 2 elevation minus Model 2 Block 4 elevation equals the average elevation difference. Histograms. A histogram is a graphical display of data using bars of different heights. In a histogram, each bar groups numbers into ranges called bins. Taller bins show that more data falls within that bin, and the overall shape displays the spread of the continuous sample data. Histogram, the percent distribution of Earth's elevations. If you were to measure the elevation relative to sea level at every location on Earth's surface and plot into a histogram showing percent distribution of elevations in 50-meter interval bins, then you would get the following histogram. This histogram shows two distinct concentrations of elevations. 0.8 kilometers, the average elevation of land above sea level, negative 3.8 kilometers, the average depth of the ocean below sea level, producing an average elevation difference of approximately 4.6 kilometers. In your lab assignment, compare the histogram average elevation difference of approximately 4.6 kilometers to your calculated elevation difference from your previous lab question. Now complete your lab assignment for Part D, Connect Isostatic Equilibrium Observations. Then watch Video 6, Part E, Bathymetric Measurements. Please address your questions to your lab TA.